best lesson in your history of mathematics. It's so good. It's good because it's awesomely powerful. And it's not that difficult, especially if you kept up with last night's homework. If you did last night's homework, or if you really understood it really well, you're not going to think this is a big deal. Okay? So, the learning goal is the same. This whole chapter is 2 equations, solve them. It's the only thing we're learning in all chapter. We're learning all these different ways to do it. Recall, elimination is a method of removing a variable from a system of linear equations by creating an equivalent system in which the coefficients of the variables are opposite. Wow. That sentence does not do elimination justice. The sentence you should use. Go home tonight. Mommy or daddy asks you, what are you doing in math? You should say, we're getting 2 variables the same, and then we're adding or subtracting to get rid of them. So good. Yeah? That's a better sentence. No, this is the technical sentence. It's correct. Equivalent linear system. Okay, we're getting a red highlighter ready. I think I'm going to need the red highlighter. Those of you who are Staples nuts, heading to Staples this weekend to get yourself a set of highlighters and color code your notes. I've got some. Maybe I got some highlighters. If you're just dying to have a set. Here comes the red highlighter. Red for this is vital. When you multiply one or both equations by a constant other than 0, don't use 0. 0 doesn't accomplish anything. It just makes everything 0. You create an equivalent linear system that has the same solutions. Whoa. This gives you permission to multiply the 2 equations by any number you want except 0. Go ahead, multiply it by 5 if you want, multiply it by 2. You'll end up getting the same answers. We've been doing this the whole time in equations, friends. Look, you've been doing this in equations. Let me just show you what I mean. 3x equals 12. Hopefully you know how to solve this. Your method was to divide both sides by 3. We knew that would give the same answer. I said 3 and wrote x like that. So we've been using this rule the whole time. We've been using this ability to do whatever you want to the equation, as long as you do it to both sides. Okay? And we're going to use that weapon to have some unbelievable power here. Let me read it one more time because it's so good. When you multiply one or both equations by a constant other than 0, you create a new linear system that has the same solution. So you'll get the right answer. Now, like yesterday, there's the way this note's typed up is there's an exemplar example that I'm going to skip over and come back to. It's easier to understand the exemplar after we do one together. We're good enough in this class, so we'll just talk about this one together. So I'm going to talk for 90 seconds, maybe 2 minutes, about the situation with this one. And hopefully just what I say is just enough for somebody to go, oh, I'm going to take what's in the red highlighter. I'm going to take what's on the board and what he says, put them together, and do some, what's the Harry Potter spell? Something Levioso. What do I say? No one knows the saying? If you remember it, tell me. I'm going to do some Levioso stuff on this and make it into a system of equations that you can handle. In fact, after you see one example, I might do one line, and you might be like, I'm going home. I'm done. That's all I need. Thank you very much. See you later. Let me analyze this one as if it was in last night's homework. X plus 2y equals 10. 4x minus y equals negative 14. Okay, which one matches up? Because in the homework, they were all rigged up to match up. You go, do the x's match up? X and 4x. All those ones don't match up. Adding x with 4x will not eliminate x. Subtracting x and 4x will not eliminate x because you'll get like negative 3x. Okay, it must be y. Must be y. 2y, negative y. Add those together, it doesn't eliminate. Subtract those, they don't eliminate. Mr. Todd, you're a big fat meanie. Why would you put a question like that up there? Well, I wouldn't on day 1, but on day 2 I will. Can anyone put the red highlighter together with what I just said to make this work? Future teachers, feel free to do the awkward pause. Just in case anyone's thinking about their weekend. the fact that they didn't finish their homework. Is Mr. Todd checking homework today? I didn't finish it. It's the one day I didn't finish it. He's going to check today, I know it. And bring their brain back here. They give everybody a chance and go, this is important. Even if you don't know the answer to the question, at least your brain is ready. You're like, I don't know what to do. Someone's going to tell us, and you'll be like, oh. What do you like? I could cancel the 2y and I could move it over here, but it's not eliminated. It's still in my way. It's still in the equation. Yes, we can move the y's back and forth and the x's back and forth across the equation, but I'm talking about setting it up in such a way that we can eliminate it. Not eliminate it from the question. Eliminate it from the equations so that I can solve. She's right. She's right. And I'm going to do it beside. Some textbooks do it below. I think it's easier to see beside. So here's what I'm going to do. I'm going to label them 1 and 2. And what she said is, do nothing with equation 1. I don't know if she phrased it like that, but that's what she meant. Don't do anything with equation 1. It's perfectly good the way it is. X plus 2y equals 10. But then she said, take equation 2 and multiply it by the number 2. We can multiply it by anything we want. 2 is the number she selected. Now, if you don't know how she selected 2, watch what happens and see if you agree 2 was wise. And then you got to get to the point where I would know to do it. The way we write this is we write 2 times equation 2. See how nice that is with the little circles for the equations? Real easy to write. You don't have to write out the sentence, multiply equation 2 by 2. You can just go 2 times equation 2. And so if I do that, I get 8x minus 2y equals negative 28. And let's just savor that for a moment and see what she's accomplished. Is this now ready to do elimination? Yeah. Positive 2, negative 2. So the first level of understanding of these type of questions on elimination day 2 is look and see if there's a number you can multiply one of the equations by to match up. That'll be true sometimes, multiplying one of the equations. Now let's do what we did yesterday. We'd now add the 2 equations. And again, if you did a bunch of the homework, you're like, well, this part I got. See, this is why it's so important to do the homework. You don't want to be in the next lesson going, I don't get what you're doing there now because I didn't do the previous stuff. And things start to snowball out of control if you're not careful. What's 8x plus x? 9x. 2y plus negative 2y? Eliminate it. That's what we're trying to accomplish, is to eliminate one. It's not gone from the question. It's still in the question, but it's gone from my equation, allowing me to do great stuff, allowing me to solve for x. 10 plus negative 28? Negative 18. Feel free to rely on your calculator. I was talking to somebody in Math Help Room about this yesterday, and they were having trouble. They were surprised they were doing mental math wrong, because they're a very smart person, and they were used to being able to do mental math. I said, here's what happens. In the middle of learning to do elimination and adding x's and y's, your mental math goes weak for a minute, because all your brain power is over here in elimination. So maybe tonight is a night to use your calculator a little more, to go, normally 10 plus negative 28 is something I can do in my head. But maybe tonight is like, but I'm going to count on my calculator because I'm learning something new. I'll get back to juggling 4 balls at once, but first I better just learn how to juggle these 2, yeah? And then I'll get back to mental math. Hopefully you know the next steps. Divide these both by 9, and you're really hoping this comes out nice. Many of the questions do, but it doesn't have to. I don't want you to think it has to. There are some questions that come out to fractions. I like putting a box around that because I'm so happy, and I know I'm going to need that as I go along. What's next? Hopefully these steps are getting better. What's next now that I've got the x? Sub x into anywhere. He likes equation 1. And maybe you're turning it into an algorithm in your head where you're like, then I take it and I put in number 1. Great. I love that. Other people might look and go, well, I'm going to take a look and see. I'm going to look at the 2 equations and see which one's easier to sub into. And maybe there's one that's easier or not. And maybe you're good enough at algebra that you don't care. You're like, I'll just sub it into whatever one I feel like. So he says into equation 1. So I get negative 2 plus 2y equals 10. I think he's chose the right equation. He chose the easier one to sub into. Why not use the easier one? And I'll do these steps quickly, not because I think, not because I'm trying to rush you or act like, oh, you don't need explanation here, but it's important to try to keep your brain on task here and not get distracted by a little algebra. Hopefully you can do that with effort. That part you can do. And it's not the point of this lesson. The point of this lesson is how do we get variables eliminated. So, I've got an answer. Then check it. Please, friends, will you check it? In your homework, yes, you got your answers there. And maybe your check is just look at the bottom and make sure you got it right. Maybe your check is left side, right side. Maybe your check is, I like playing with Desmos. Let me just plug these in. The advantage of Desmos is while this is happening, you're not losing track of what we're doing. In the end, these are two lines that will meet once or never or always. You know, that's what we're trying to accomplish in all this. So that's very visual. On this particular one, I'll do the left side, right side check because that's the one you're going to want on quizzes and tests. And I marked your quizzes. And most people had this check down pat. A couple people, I wrote a little note saying, ooh, there's a little faster way here. You can tighten this up a little bit. So if you want to come see me, I'll walk through that. So I'm going to check number 1. You go left side, you do right side, and you go, okay, the left side of equation 1 was x plus 2y. The right side was 10. And here I got negative 2 plus 2 times 6. And when I do negative 2 plus 12, I get 10. By the way, I did notice that one of you didn't show the steps here. So either you're so good at it you don't feel like you have to show the steps, or you're like, I know what you want to see. There, 10 equals 10. There, I get the marks. I was like, the check's for you. The check's for you to make sure the answers are right, just in case you made a little mistake. And it makes you feel good. Even better, if your answers come out correct, you don't have to go back and check this anymore. It's to save you time. So don't cheat on a check. That's ridiculous. Huh? I don't know if they did. I couldn't tell if they cheated. Left side, right side. I'm checking equation 2 now. It is possible for one of the equations to work and the other one to not work. So you got to check both. 4x minus y equals negative 14. So I go 4 times negative 2 minus 6. Negative 8 minus 6. Oh yes, negative 14. I like putting check marks beside them, but you don't have to. It's like, literally I checked it. It's checked. One final statement. Therefore, the solution or the point of intersection is negative 2 comma 6. But let's not get distracted by all those steps. Let's stay focused on, hey, if they don't match up, multiply one or both equations by something that makes them match up. Okay? Do you have questions on that? Knowing that I'm going to do a couple more. How many more do I got to do? I'm going to show the exemplar and do 2 more. In theory, maybe they get a little tougher than the one I just did, yes? Okay, let's go to the exemplar. There's one in your notes that has an exemplar. It shows you all the steps. So you can look back and go, here's a nice typed up one. But let's look at what they did in this one. This one's a little tougher than the one we just did. They looked at 2x plus 5y equals negative 26 and 3x minus 4y equals 30. They chose 4 and 5. Let's make sure it works and then use that to help us make our decisions. They multiplied the first equation by 4 and they got 8x plus 20y equals negative 104. And they multiplied the second one by 5 and they got 15x minus 20y equals 150. Do you agree that they used a potential good choice? Does this now match up? Yeah, it matches up. 20 and negative 20 right there. That all matches up. But here, how did they decide? What did they do to choose the 4 and the 5? Good news. If you can't see it, it's laying right there. The question will tell you. It's laying right there what numbers to use. Where did they get 4 and 5 from?
The finding a common denominator?
Yeah, the word isn't common denominator, but you're right. They looked at this and said, well, that's a 5 and this is a 4. So if I multiply this one by 4 and this one by 5, it's going to work. You're like, that's simple? Just multiply this equation by the other coefficient and the second equation by the first coefficient? That works every time. Every time. Can there be better choices? Yeah, there might be. But if you just want an algorithm, you just go, okay, choose one of the variables. You get to choose which one. To match them up, multiply the first equation by the coefficient from the second one. Multiply the second equation by the coefficient from the first one. I will say, you might want to choose a negative number if they're not going to match up. If you don't want to do subtract, we can do subtract, but I'll just mention that. Let's see what the notes say. Notice if you add these equations together, the variables don't eliminate. So if we choose to multiply by 5 and by 4, that gets the equations to match up. So it just says what I said. That's not what you want to see. That's just a reference. Let's go after this one. It looks a lot like the example that's already there, doesn't it? It's got 5s and negative 4s in it. So I'm going to do this one a little bit differently. You've got the exemplar that you could do it that way. I'm going to go after the x's. I want to do a little more teaching here, so I'm going to go after the x's in this one. And based on what I said, I need a brave volunteer to tell me what I should multiply each of these equations by, and probably I'm going to modify their answer. So it's got somebody brave who's willing to let me modify their answer. Peter, what do you suggest?
I'm going to multiply equation 1 by 4.
He's going to go by 4. And where did he get the 4 from? He just took the coefficient there. And then the other one?
Number 2 by negative 3.
Oh, he's a step ahead of me, friends. I didn't think he'd catch it. He did. To avoid having to subtract, he's going to choose negative 3. Not 3, negative 3. And that will make them line up positive, negative. That will be the least error-prone method. In fact, sometimes we teach it the first time we teach elimination, and we say always make it so it's addition. But it's easy to make a mistake with subtraction. It happens all the time. So we use addition if we can. So he says take equation 1, and I like doing it beside. You can do it underneath. Take equation 1, and he's going to multiply it by 4. And equation 2, though, he's going to multiply that by negative 3. It's fine if you're out there thinking, I think I would go after the y's in this question. That's fine. I'm trying to teach multiple ways so that you're ready for whatever question comes up for you. So there's one like this in the exemplar where they went after the y's. I'm going to go after the x's. So when I multiply everything by 4, the most common error in these is to not multiply everything by 4. Lots of people go, okay, 12x minus 16y, and then they just write 7. That will be your common error. You're so focused on the x's and y's, you forget to multiply everything by 4. And then he multiplies the second one all by negative 3. He gets negative 12x minus 15y equals 96. Do you see what he accomplished by using the negative? Now it's positive 12 and negative 12. Then I don't have to subtract. You're like, I don't mind subtracting. It's going to be okay. Yeah, it's no problem. You can use subtract. And the homework, I think, forced you to use subtract sometimes. But if there's negatives hanging around, subtracting negatives might throw you just the curveball you don't want in your life. So we'll talk a lot about trying to get these opposite. The rest of the steps, at this point, you're like, your brain shuts down. You're like, I did my homework. I know what to do now. Add the 2 equations. 12x, negative 12x, he lined them up nicely. The x's are gone. Negative 16 plus negative 15, because I'm not subtracting. I can do that with mental math pretty well. Negative 16 and negative 15 is negative 31. 98 and 26, oh, come on. Don't reach for your calculator. Adding with 90s somethings is not bad. Yeah, you can do it. 96, I'm not going to add all the 28 first. I'm only going to add 4. That gets me to 100. Then I've got 24 left to add. 124. Give yourself a chance on the mental math sometime. Keep those mental math muscles moving. What's that? Oh yeah, divide by negative 31. Answer negative 4. I love a box around it because I'm going to be looking for that y later anyway, so why not put a box around it so I can find it easily. And then sub y equals negative 4. Well, let's do a little analysis here. Let's just refine the method a little bit. Looking at those two equations, which one's easier to sub negative 4 into? He likes 1. Maybe you like 2. But at least take a moment and think it over, just in case one of them is way easier. But I think they're pretty equivalent here. So if you're not sure, well, I'll just go with 1. 3x minus 4 times negative 4 equals 7. 3x plus 16 equals 7. Bring the 16 over. And divide by the 3. It could be those steps are starting to become more automatic all the time. If not, if you're like, no, this is where I make my mistakes, don't rush that, Mr. Todd, that's where I have problems. I'm like, yeah, then do as many as you can till you get this practice down. Because that algebraic practice, we're going to need it, folks. We're doing more and more algebra as the semester goes along. So just keep practicing that algebra. I can tell you that it's not the smartest students that usually are the best at algebra. It's not. They're often too arrogant to practice. It's the people who are like, no, I'll just do another one. I'll just try another one. And they get much better at the algebra. So let's do this one with Desmos. Just so we keep an eye on the visualization that's going on here.
Is there anything stopping you from just doing doing y in this situation?
No, nothing. The only reason I did it is because the exemplar example did y's and a similar one, so I did x's just to go.
Would there ever be a reason where you shouldn't do y? Or where you wouldn't have to go into multiplying by negative numbers?
Let's say all the coefficients are positive, then you're going to have to multiply something by negative to line them up. Yeah, good question. 3x minus 4y equals 7. Notice this graph, or this Desmos does not care that you're not in y equals mx plus b. And 4x plus 5y equals negative 32. Answer, if I hover over it, it labels the point for me, negative 3, negative 4. So Desmos is very nice like that. And you could use this too. Let's say you're doing a question, and it comes out to fractions. You're like, I don't know if it's fractions. You can double check in Desmos and go, oh yeah, it's right. This one happens to be fractions, okay? So I did the check that time with Desmos. And I'll do, because I did it with Desmos, I'll make the conclusion like this. Therefore, the point of intersection is negative 3, negative 4. Is it okay? All right. Last example already? Yeah, because it's the procedure is fairly, it's like an algorithm. Do this, then do this, then do this. It's not like I can come up with 16 different examples that are different. So let's see if example 3 I did anything fun. No, looks the same. Which one would you go after? Would you go after the x's or the y's? She likes going after the x's. Maybe you like to go after the y's. Challenge yourself, maybe some of you. Let's try it out. Let's not find out. Let's not wait till tonight to find out you don't know what you're doing. Try right now. Choose x or y and go after it. And I'll take it up in just a couple of minutes. Because in a couple of minutes, you'll either be well on your way or you'll be stuck.
Say you didn't want to add the numbers, could you just subtract them then? Do the other way?
Yeah, if it happens that you look at it and you feel confident about your subtracting. You're like, I'm good at subtracting negatives. Thank you, Mr. Todd, but I'll be okay.
All right.
But lots of times, even after people try a few, they're like, every time I make a little mistake, it's on a subtracting one. So I'm going to switch over and do what Mr. Todd suggests and do adding. But you don't have to, yeah. Try it whatever way until you get your own method. I'm going to do the first step. I'm going to do X's in red, Y's in blue. So if you're checking your answers, okay? If you chose some different numbers, you don't have to do it exactly like mine. Over here, I'll do it in blue. My sixth sense is telling me the answer is not, is it a whole number? Yeah. Oh, it is a whole number. Okay. If you're under a fraction, stick with fractions. So over here in blue, I'm going after Y's. I don't know, if you made the same choice as me, whether you did X or Y, that should be what it first looks like. Oh, it is whole numbers. I thought it wasn't. I don't know why. I started moving faster because I started here talking. I'm not getting down on you for talking. That's not what I mean. What I mean is I meant, oh, a lot of people are done, so I can roll along here. Yeah. So. Friends, I want to talk about one thing about doing these on quizzes and tests. A couple people ran into this difficulty, I think, on the quiz or test because I could tell by the way they did their work that they ran into a problem where they realized They did the question, and they were checking it, and it wasn't working. They realized there was a mistake somewhere, and they couldn't find the mistake. That's a major algebraic problem, actually. When you make a little mistake in algebra, it's tough to find your mistake because whatever mistake you're making in your head, you'll make it every time you go to do it. Sometimes the only way out of trouble is to go and do it another way. So doing this both ways like this, maybe you're on a test, you're like, I know it's not right, but I can't find it. I can't find it. You took forever and you can't find it. And you're running out of time. There's only 8 minutes left. Go, forget it. I'm not eliminating x's. I'll try eliminating y's. And then you don't make the same error over here, and then you find the problem. Well, you never do find the problem, but at least you get the answer. So my check today in this one is I did it both ways, got the answer the same the both ways, and went, that's a pretty good way to check as well. Now that doesn't get me when they say check your answer on the test, they mean check your answer. Show me left side, right side, or your version of left side, right side, and show me that you know how to check these. And it's for your own benefit. It's not for me. I mark it because I'm like, I'll give you marks. I will pay you with marks to be a good checker. Huh? How'd it go? Did anyone make a little mistake that they'd like to share with others so that you know going into the homework where the mistakes can happen?
Copying the question wrong down?
Copying the question wrong. Geez, I don't know what percentage that is of mistakes that people make in algebra. It might be 50%. 50% of the time, it's just I copied it down wrong. So when you get a wrong answer and you're comparing it to my answers, you're like, I think Mr. Todd got this wrong. I did it all perfectly right. That checks out. I did it. It's all good. And then you look at them and go, whoops. That was a -6, not a -9. What was I doing? Happens all the time. That a copying error. Where else might there be errors that come up here? Yeah, it's easy to miss the negatives. We've got a saying in calculus. So all the way in calculus, we always say, it's always a negative. We'll go through a whole chalkboard of algebra. I'm not exaggerating. We'll do algebra from there to there, all the way through. Can't find what happened, and way back here, oh, that's a negative. Yes? Not bad to fix, though. It's not bad to just go, okay, that's negative, that's positive, that's negative, that's positive. Okay, done. We usually fix it in a couple of seconds. But watch out for the negatives. It's always a negative. Any other errors that came up? Okay, I'll share one. And I shared it before. The most common error in these is when you multiply an equation by something, you forget to multiply the constant by the number as well. You multiply the x's and y's because you're so focused on x's and y's, you forget to multiply the constant as well. Okay. Assigned work, all in the textbook, 54 to 55, 1, 3, 4, and 6. Boy, I encourage you to kick these because word problems is coming Monday. It's a very difficult lesson to get all those word problems figured out, but we're going to want to be in this position. If we can at least get the word problems into equations, we want to be in the situation on Monday where it's like, okay, now that we got the equations, we're good at that. Yes? We want all that focus of that lesson to be on, how do I make the equations? As long as I got the equations, I'll be fine. And then on Monday, we can just use our brains to focus on how do I build equations. And then that's the last lesson of the chapter. When's the test? We have scheduled the test for Friday on purpose. We have made a long gap, even though I'm done teaching on Monday. You'll have all the way till Friday to get ready. We want your first chapter to go very, very well. So we've left a big gap in there. But you got to get caught up this weekend on homework. Got to, so that you're ready for Monday's lesson.